Welcome to part 3 of the Module 7 exam review. So we're going to keep going into this. So we want to evaluate this formula here, P equals 2L plus 2W, which is nothing more than the perimeter of a rectangle when L equals 8 inches and W equals 5 inches. So we just plug these in once again. 2 times our length, 8 inches, plus 2 times our 5 inches. 2 times 8 inches is 16 inches, plus 2 times 5 is 10 inches. So grand total, we have 26 inches of perimeter in this rectangle with length 8 inches and width 5 inches. Okay, so let's look at this next one here. We're going to be solving some equations for variables. So we're solving V equals 1/3 BH for H. So the first thing I want to do is get rid of that 1/3. To get rid of the 1/3, we can multiply by the reciprocal, 3 over 1, 3 over 1. And 3 times V, because V is V over 1, we get 3V equals over here. The 3's cancel, the 1's cancel, and we get BH. Okay. So now we're trying to solve this for H, so we need to get rid of the B. And BH is B times H. So we want to divide both sides here by B. The B's cancel here, and we get that H equals 3V over B. So that is that one right there. So looking at this last one here, we have A plus B equals S plus R. We're trying to solve this for S. So we want to isolate the S. So we need to get rid of the plus R. So we subtract R from one side, but whatever we do to one side, we have to do to both. So subtracting R from both sides. Now on the left we have A plus B minus R. None of those are like terms. So we have A plus B minus R equals. Over here, R minus R is 0, they cancel, so we get S. So S equals A plus B minus R. Okay, now we have a couple story problems, it looks like. And for this next one, it says find the sum of 3 consecutive even integers. The sum of 3 consecutive even integers is 240. Find the integers. So once again, if we think about even integers, it's like 2, 4, 6. And those would be 3 consecutive even integers. Or 26, 28, and 30. So the distance between the first one and the second one is 2, and the distance between the first one and the third one is 4. So we're going to let the first integer equal x. If the first one's x, the next one is going to be x plus 2. And the third one is going to be x plus 4. Okay, so that's what we have. So just like if we had the first one is 6, we have 6, we plug into the first one 6, plug in the second one, we have 6 plus 2 is 8, and then the last one would be 10. So the sum means we're adding these things together. So the sum of 3 consecutive even integers is going to be nothing more than x plus 2 plus x plus 4 is means equals, so equals 240. So now we want to combine like terms. We have 1x, 2x, 3x's. 3x plus 2 plus 4 is 6 equals 240. And then we can get rid of the 6 by subtracting 6 from both sides. And those cancel, so we get 3x equals 234. Then divide both sides by 3. So 234 divided by 3 is 78. So x equals 78. Now, so the first number is 78. The second number is 2 more than that. So that's 80. And the third number is either 2 more than the 80 or 4 more than our 78. Either way, we get 82. And those are the 3 consecutive even integers that we're looking for. So the numbers, the integers we're looking for are 78, 80, and 82. Next one we have Stevie bought a stereo for $290 and put it on sale at his store at a 65% markup. What is the retail price of the stereo? So if you pay $290 for a stereo that's $290, that's 100%. You're paying for 100% of it. Because he's marking it up 65%, the price relative to this $290 is going to be 165%. The 100% represents the 290. The 65 here represents the markup of this. So when we look at this, we want to figure out what is this new retail price. So 165% of 290 is 290, 1.65. So turning this percent into a decimal. Just do this in the calculator. 290 times 1.65 is $478.50. So that is the retail price of this. So he bought it for $290. He wanted to make some money at his store, so he marks it up 65%, thus charging 165% of what he bought it for. And that's that one. So moving on to these next inequalities. X is less than 1. We want to graph this inequality. So first thing I notice is we have less than, not less than or equal to. So we know we're going to have an open circle because we're not including that 1. 1 is not less than 1. It's not included in our solution set. Now if x is less than 1, we want to think about all the numbers less than 1 means we're shading this way. And that's what the graph of that guy right there looks like. Okay? Now, solving these inequalities down here, I'm going to use some different techniques. Now this first one right here, we have an inequality, and when I see this, I see a lot of fractions. So what I'm going to do is I'm going to use that technique that we talked about in the past called clearing the fractions. And the way that we do this is we multiply everything by the lowest common denominator. We can say 5 is 5 over 1. We can say 3 is 3 over 1. So the common denominator between 1 and 2 is 2. So we multiply everything by 2. So we're multiplying this by 2 over 1 by 2. So we're going to do that. So we'll multiply both sides by 2, which is really 2 over 1. So our distribution here, 2 times our 5 is 10. Okay. When we multiply in here, 2 times our 7 is 14, but divided by 2 is 7, so we have negative 7x. This final distribution, 2 times our 3 is 6, so we have plus 6 is greater than. Over here, 2 comes in here, 2x divided by 2, the 2's cancel, we get x. And finally, 2 times our 1/2, 2 over 2 is plus 1. So we've multiplied through by the lowest common denominator to clear the fractions or get rid of all of the fractions in this. Now we want to go ahead and combine like terms. 10 plus 16, this gives us 16 minus 7x is greater than x plus 1. Now we need to get all the variables to one side. So I'm going to move the variables to the right, so I need to get rid of these negative 7x's. So if we add 7x to both sides, over here they cancel, so we get 16 is greater than. X plus 7x is 8x plus 1. Got to get the numbers to the left now, subtract 1, subtract 1. And we get 8x is less than 15. And finally divide by 8. The 8's cancel here, so we get 15 eighths is greater than x, or we could write this as x is less than 15 eighths. Now to put this in set builder notation, put a line and x and scribble. To put it in interval notation, we can draw our solution set. 15 eighths. We can say that's 15 eighths. Now I'm putting an open circle because we have less than. We're less than that, so it's everything over here. So when we think about the interval, reading from left to right, this is the interval that goes from negative infinity to 15 eighths. Because we're not including 15 eighths, we put the parenthesis around that. So I would be comfortable solving these types of equations, graphing them, and putting them either into set builder notation or interval notation. Okay? So we'll come back up here to do this last one. Yeah, and then that'll be good for this page. So solving this, we want to isolate the 4x first because we want to get the x all alone. So we have to subtract 5. Okay, so 5 minus 5 is 0, so we get 4x is less than 21. Divide by 4, divide by 4, and we get that. Yikes. And we get that. There we go. I guess I can move most of it around. So here we get the cancellation of the fourths, so we get x is less than 21 fourths. So to put that in set builder, put in line and x and scribble. The graph of that, open circle, 21 fourths, because we have less than, shading to the left, because we're less than that, so in interval notation this would be negative infinity to 21 fourths. Okay, so all three of these are kind of acceptable kind of notations here. We have our 21 fourths there. And hopefully that made sense, and we'll see you next time.